Hey all, today we are going to continue with our discussion on things that are similar. And when we have been talking about similar triangles, we have been writing proportions. And just a reminder that a proportion is, or they are, equal fractions. So if we are going to talk about proportional parts in triangles, we are going to talk about things that we can write as equal fractions, and those equal fractions give us a proportion, and it helps us find a missing piece. I said a lot earlier in the year that a lot of geometry is about um, figuring out what relationship exists, using that relationship to write an equation, in this case, an equation that's a proportion, and then using that to solve for a missing piece. So we're going to have a few scenarios that create proportional parts. We don't need to put a name to them necessarily. But what I have here, if you remember, these red arrows mean that those segments are parallel. And we're looking to find out how long this piece is, this question mark piece. So I want to be able to write fractions. And what I really like about these problems is that we can actually kind of see the fraction. So if I have this line, if I extend it on both sides, I can see I kind of have a fraction right here, 21 over question mark. And we're going to have a proportion, so that means there'll be an equal sign in between. And I'll have a fraction here. I don't know this top piece yet, but I know the bottom's going to be 16. And so we can find this top piece because I know this whole thing is 28. And this bottom piece is 16. So the top piece must be 28 minus 16, which is 12. And when we have a proportion, in order to solve it, we need to cross multiply. That means we multiply the top of one fraction by the bottom of the other, and vice versa. So I can do 12 times question mark, and then 16 times 21. And I apologize if my pen is skipping a bit. I don't know what's happening. My computer is not happy about this. And then we can solve this equation like we normally would. Multiplying those, dividing both sides by 12, and I get that missing side to be 28. So we establish this relationship since we have these parallel lines here, one that goes through the triangle and one that is a piece of the triangle or a side of the triangle. We get these fractions created, and those fractions should be equal. They should be in proportion, and we can write that proportion and solve it and figure out that this missing piece of the triangle is 28. So there's some other scenarios that are similar that will create proportions, equal fractions. You can see down here, I don't have a triangle, but I do have some parallel lines again. This time I have three, so I have three parallel lines. And they're intersected by these other two lines. If you remember from when we talked about parallel lines, we called those things transversals. It's good to know that, not necessarily the most important thing right at the moment. But again, we get these fractions created. I have this line in the middle, and these two pieces can be written as a fraction. So I just got to make sure that the tops of my fractions sort of come from the same side of this line. So I can write this fraction 6 over 4, and this fraction question mark over 10. So both of the tops of both of these fractions came from the left side of this middle parallel line. And then I can cross multiply, so I can do 4 times question mark, 6 times 10, and I can solve this thing. Divide both sides by 4, and I can figure out that that missing piece is 15. And you would want to make sure that that made sense. It looks like this is the longest piece. If you had to really guess, this is the longest piece out of these four things that we have labeled. So 15, just a little bit more than 10, that makes total sense. And the last type of scenario that we're going to get where we'll see these proportions show up is when we have this scenario. So you can see the little arcs in there. Reminder, that means that those two things are congruent. They're the same size. They're both angles, so they're the same shape, and they're the same size, which means if we measured them, they would be the same number of degrees. And this line here is what is creating these two angles. That thing is called an angle bisector. A bisector is something that cuts something in half into two equal parts. So an angle bisector cuts an angle into two equal angles. So this original angle of the triangle is being cut into two equal angles. We know they're equal because of these marks. So this is called an angle bisector. And again, we get these proportional parts. So this angle bisector kind of serves as the fraction bar, just like this middle line served as a fraction bar, so I can kind of extend it. And so I have this fraction 4 over 8. And I have this fraction, I don't know the top here yet, but I know the bottom is question mark. So I need to figure out what that piece is so I can complete my proportion. So if I go back to one that we did, in order to find this piece, I subtracted this whole segment minus the part of the segment that I knew. So it was 28 minus 16. If I compare that to what I have down here, I know this whole thing. It's going to be 9 minus, and then I need to subtract away this piece. Well, we don't know what that piece is, but it's labeled as question mark, so we can say 9 minus question mark. So if we figure out what question mark is, that's how long this piece is. If we subtract that from 9, we'll know how long this piece is. So I'm going to put that in there just like that. It looks funky, but that's what it is. If we knew what this was, we could subtract it from 9 to find this piece. So I'm going to cross multiply. I get 4 times question mark. And then I get 8 times this whole top of the fraction. So I'm going to put that in parentheses. It's very important. And now I need to do some distributing. So I multiply everything in here by 8. And now I have an equation I can solve. I'm going to add 8 question mark to both sides. If you feel more comfortable calling this x instead of question mark, you can just change them all to x's because that's what we're typically used to seeing. So add 8 to both sides, I get 12 question mark. Divide both sides by 12, and I'm going to get 6. So in all of these cases, this sort of extra line, in this case the angle bisector, in this case that middle parallel line, in our first question that line that goes through the middle that's parallel to the one side, they all, if you sort of extend them, create these fraction bars, and we can see these fractions. We set those fractions equal, and we can use that to solve. As always, if you have questions, I want you to make sure that you either write them down or you raise your hand when you have them. Don't go on to practice, or don't leave this lesson without getting your questions answered, please. What I want you to do right now is I want you to pause the lesson. Pause right now, and I want you to try this one. I want you to find question mark. You can use this one as an example. So pause right now, do it completely on your own, then press play, and I will go over the answer. So I'm hoping that you paused, gave this a shot, and even if you got it wrong, that's okay. The important part is that you tried it on your own, and you can see if you need to fix a mistake or ask a question. We need to find the missing piece here, so we did the whole thing, 6 minus the piece we know, 4, to get 2. This creates a fraction, 4 over 2. I have a fraction here, 8 over question mark. Notice that both of the numbers that are on top of my fraction came from the same side of this middle line. And then I cross multiplied and solved to get that missing piece to be 4. I think that answer makes sense. It's smaller than 8. It looks like it's probably the same size as this one. That is 4. And so I think we can be pretty confident with our answer. So something new to the lessons that I haven't asked you to do just yet, but I want to ask you to do now is I'm going to ask you to answer some questions about these ones. So make sure you watch all the way to the end of the video because there's going to be some questions that pop up that ask you about these 3 problems. And it will be part of the grade, so you want to make sure you do them and you want to make sure you do the best you can. So if you need to use the questions we did together for help, please do that. As always, if you have any questions about this lesson, ask me. It's important to do some practice when you're done with this. The practice is what gets you better at this. Again, ask for help if you need it, and good luck.